I guess they're really, really desperately trying. Okay, now this right here is going to be what we're doing for standard deviation. This is the formula right there. Okay. Now, what we have here is we have to first calculate an average because this x with a bar over it right here, that's an average. Okay. So I'm first going to go through this. To get standard deviation, you use this formula. So it would be standard deviation equals this formula. Okay. And then this is a square root for the entire thing. Now, when you use long formulas like this, you should break them up. Okay. And do it piece by piece. So you don't get confused, you don't accidentally type in your calculator, then it doesn't count. Okay. So this right here, this is called sum up. It's an epsilon, looks a bit like an E, right? Everybody see that okay? Okay. And see how it has I equals 1 and then on top of n? So what's going to do is you're going to do this stuff in here for a series of data. Okay? You're going to do it multiple times. How many times, they can't tell you, because you could do this 100 times if I made you weigh out 100 pennies, right? You could do it 3 times, what we're going to do. In fact, there were some groups that did it 4 times. They had 4 pennies instead. Okay? And so everybody can end up doing this different number of times. You can do standard deviations for massive populations, okay? Or you could do it for 3. Realistically, if you do it for less than 3, that doesn't work very well. And you just give your result. And you definitely can't do it for less than 4. Because we need get back right now. Now, the next thing we're going to do is we're going to plug these in. So the first thing we need to do is an average. I'm going to make up values for the pennies. We are going to go with and so these are going to be my masses for my pennies. Okay. You'll want to write those down on a separate place, not your packet, because these are not the numbers I gave you. Okay. I write like on the top here. Sure. Okay, just make sure you have some fixed there. So yeah, you can write on your packets, just not in the answer part where you're supposed to do the calculation for the numbers I gave. Otherwise, okay. So what you'll do here is when you're doing an average, you take your values, you add them together. Okay. Can I count on you all to do the calculator work for me? Thank you very much. Please go ahead and grab some calculators out. I'd actually recommend everybody grab the calculator out so you can test whether you actually understand how to use the calculator and use your calculator. That way you can go, oh crap, I got a different number. In which case, there's something wrong. Somebody wrong. Thank you. 6.302. And that sounds perfect. Because you're all about 0.1, right? Okay. And so the next thing we're going to do is this is an average, so I have to divide by the number of these that I did. So 3 of them, right? And that number is called n. Okay. So I divide by 3, and I get 2.1, and I can't do the last one. That's it. Okay, then that's perfect. Now, when you're normally doing this, by the way, you normally want to give a few extra decimals. And would you give me the next one? 6? Does that round up to 7? Okay. This is how you represent it if you want to represent like that. So you do the next one that's not significant as little subscript numbers. That means the next digit is 7. So this is just 2.1007. I'm just telling you it's not significant. You'd round this up. You don't round though until the end. So remember, you always keep an extra couple decimal places and don't round until the very end. Actually, I'll keep two so you guys don't round here. What's that 6?
It's 6.
6. Oh yeah, it'd be 6 repeating.
It's 6 repeating. It's 6, 5 times instead.
Okay. And that's my average. So we've done the average. No. And your answer, just round up. So when you write your answer, just go ahead and round up. That's fine. Make sure you put your units. But I need that for you guys for your calculations next. So calculations always leave extra decimal. Okay, this number is going to end up really small, by the way, for the standard deviation. Your number may end up bigger. Okay, it could be bigger, it could be smaller. Standard deviations are not all the same. Because it's actually a measure of uncertainty. Okay, so we're going to do this formula next. Is everybody good with that part so far? Okay. This number we just got, this right here is the mean. Okay, that's that x bar. Okay, so the next thing we're going to do here is I am not going to try to put everything into that formula. You are going to mess up on your calculator almost 100%. Okay, so what I'm going to do is I'm going to break this apart. And so what I'm going to do here, I'm going to write the pieces that I'm actually working on. Okay, so the first thing I'm going to work on, can you even see over here? Okay, I'm going to try and move in. I'll do sort of stuff here first. And if we move over, can you see okay? Yeah. Everybody else. Let me know if I start writing on places in this building that you can't see. Please keep in mind that like I only teach you guys for here. So I don't know the classrooms that well. Yeah. So see how I pulled a part of that formula? So I pull a part of the formula, and I'm just going to do that part of the calculation. Okay, so I have it broken into very manageable pieces. All right, so the first thing I'm going to do is this is individual value. So I pull up individual values here, 2.100, 2.105, 2.097. Okay, so I did my individual values. Then I minus by my average. Basically, that okay? Now I'm gonna figure those out. So notice that some of these values will for sure be positive, some of these values for sure will be negative. Okay? By the definition of an average, you have to have both. If you don't have both, positive and negative, something went terribly wrong. Okay. And so this first one I believe is negative 0.006 repeating. And then the next one is negative 1.6 repeating. Make sure you calculate along with. You also need to test your ability to put the calculator. Oh, this isn't. That's not.
0.0.
Yeah, really. Okay, and then this next one's a negative number, and it is 0, 0. And so that's that differences that's inside of it. Okay? I need to do it 3 times, so I have 3 individual sets of data. Okay? Did you? No, you didn't. So you may get on these numbers, something like your number was 6 like this, right? And then E, then negative, right? Okay. So you may get something out like that whenever you do this on the calculator. What that number here means is it's 6.66 times 10 to the negative 4, which is moving that decimal place 4 times that, right? It's just that. Okay. So it's the same number. It's actually a historical thing. So back in the day, yeah, had so many characters that you could do on a screen. And even now, your calculator only has so many characters you can do on the screen. And so they shorten that number of characters here so they can fit more decimal places. Capital E, meaning exponential. Okay, so that right there, we got our numbers. Everybody good so far? Okay, what's the next thing I need to do? So again, this was the part in the bracket, right? Right. So we're going to square these. And that's going to give our answer down here. So I would ask that everybody sort of breaks up into teams and does, let's call it this side of the classroom over there. You're all responsible for this one. You all are responsible for the last one. And then our middle people here, include you. Okay. So everybody use those calculators. Do this calculation. I just put on the board here. That has a squaring of that value. Roll our first. Middle is the middle. Last one. That way we can make sure we can get on the exam, you know, calculator. So would be shocked about how many people have gotten bad grades on exams because they didn't understand their calculator. Really shocked. They can be very different. Especially if you get an HP. They let you use an exam.
Then the next year they taught.
The best part is that was always going to happen, though, right? Because as soon as they they must have not known how to use it themselves, because nobody would ever give internet connected calculator for exam.
It was one of those classes.
Yeah, it was also. You know, you can do that to the TI-83s that I gave you guys. In fact, one of those has a game. Funny note, if somebody grabs one of the calculators that I had from my middle school days, there's a game on it called Drug Lord. Sell drugs and murder. I never played it off. Yeah, they closed the gifted school, and I had to go back to regular school. And I actually ended up teaching my own class. Two of my classes, they had no teacher. I did not go to it. But, yeah. I also ended up with twice. It wasn't blood and crips in my area. So the next town over actually was. My area was different. I don't know if there was no. My area, they broke the mayor's daughter's legs. They broke her legs because she refused to pay them. Yeah, that's where I was. And my parents sent me in there with $100 shoes. Remember, this is back a while, right? It would have been like $100 shoe. I got it. I got into a fight with 3 people. I was trained by a world champion martial artist. He had won multiple world champions. I'm like actually like super. I know. I seem so low key. Nobody ever expected. Never started anything from me either. So. Okay, everybody. Everybody have your answers to these. Okay. So what is the answer to this one? Mhm. You will give me the scientific definition. Let's do the 0 sum. How many 0? 6. Oh, you did the yeah. Okay. What was the? Did you get that? Okay. Anybody get anything different than the top one? It's 6 times 6. You should be right. It should be basically twice the number of zeros here. Be there. There. That sounds about right. Did anybody not get that? Okay, so the next one. What's the next one? 4 zeros. And then 197. Yeah. So are we like supposed to round them? Did like the so for these, you would normally want like 3 sig figs, but for the one I'm writing up here, I don't actually need all of it. In fact, I'm only going to need 2 sig figs or 1 sig fig. For right now, you shouldn't round. You should actually write these out at least 4 sig figs in your own doing calculation. Okay, what's the? Did anybody get any different answer for that second one? And the third one. So they should never turn out negative. If it does turn out negative, then what's happening is you need. Can you guys just tell me the numbers? Numbers. This 4 is 0. Excluding the 0. 4 0. It was 5 0. So it's just how it is. Okay. I got 1 2 1 2 9 6. And you got 1. Okay. Okay. When you put this in right here with extra 6s, what does everybody get? So when you put this in, so we put 0.003666666. Okay. And then we put square. What do we get? 1.34 repeatings. Everybody getting that? Okay. So I'm making everybody do it again because we need to get the same answer. If we're not getting the same answer, we have a problem. Right? Okay. 1, 3, reset. Now you get to hold it over everybody's head.
So why is that not the?
Hmm?
Why is that not the other one? The other one? That good?
Yeah. You just put in the 3. We were answering it for this one, the last one. 0.0036 that we're putting. And we need square. Okay. Now that's the answer so far. We are up to this point right here. What we need to do next is we need to do the sum of, and so we need to add these together. Okay. Please start adding those together. While you guys are adding these together, I'm actually going to start over here. Place. We need to do the n minus 1. Get those added together. Again, make sure everybody does it, because if you don't do them, you'll never know if you actually do it correctly. You're not going to understand. You need to do them tonight. Yeah. All the part 4. Here. Wait. Could be 4 zeros, I believe. Yeah, so what's happening is this, if you use the numbers I wrote out here, you may get a slightly different answer. If you use the ones you didn't round off, you get a slightly different. What do you mean that last decimal? Okay, so by the way, in case you're wondering, you actually just need to add these together to get basically your answer. This one's much smaller. Okay, so that's the answer for the sum up portion. So we answered the sum up portion there. We need the n minus 1. So what was n again? Way back again. Okay, and so we're going to take this part here, which is the top, we're going to divide it by 2. So we're going to get an answer from that. By the way, when you divide by 2 on a number like this, you can make your life a little easier. So that's 1.5. Put 3 there, right? Divide that by 2, right? That'd be like 6. Divide that one by 2, and that'd be a, be something like that. Is that correct? Now, we have done everything inside the square root. Now we need to do a square root. There's actually 2 ways you can accomplish this. You can put square root and then type answer. Second, usually answer. The other way you can do this, if you have this number in your calculator already, right? And so then you can go, where you can go, 2 to the power of, that's 2 to the power of symbol, right? 25. 25. That right there is the exact same thing as This right here, this is a square root. It means the same thing. If you have a value, some value of y. Okay. It's not a 3. That's sum. Yeah. That one up there. Yeah. That's epsilon. No, it doesn't. Okay. So actually the answer, once you do that, what did everybody get for a number there?
Oh, I did see it time.
That makes 0, 0. So I'm gonna put 0 down here. Okay, so this number right here. No. It's a. You all are around the end. You're all different. Okay, so what we need to do here is this right here is called the standard deviation. This is actually what the uncertainty. Okay. Remember how we were talking about significant figures? So my significant figures for my original number was 2.101 for my average, right? And what this means is this was actually that source of error that we were talking about. 2.101 plus or minus 0.004. So that would actually be our pennies would range between. Typically about 70% of our pennies will range between. Which is again 2.101 plus or minus our standard deviation. See how this standard deviation ends at the same decimal places here? That is literally the error in this number. Remember how we were like the uncertainty error is where we take the sigma. That's why we have a sigma. This standard deviation right here is creating that sig fig right. Right. That's actually the next page. That's finding the uncertainty. And then we've written it, the standard deviation is the uncertainty. And then we've written them all together in a cohesive statement. So if you look at your packet, the next thing on the packet, the next page, is percent error. That has an equation up at the top. That's that same page, first page of the packet. And then you have a statement that you're supposed to write a sentence. Okay? It states that sentence in terms of, I don't know. I have to look down at the deal. I forget if it's rubber stoppers or pennies that they put the statement in. Okay, see this one right here? Discussing error. Okay. So this discussing error here, see it has statement here, the average mass of the rubber stopper was, you're going to do the same thing for a rubber stopper, right? And so the average mass was 52.34 grams plus or minus 0.024 grams. You don't actually have to put the grams both places. You can just put it at the end. Okay. And so they want you then to, well, this packet wants you to write a statement like that for pennies. Okay. So you're going to write it using your average, your standard error. And that statement would be like this. The average mass of the pennies was, in our case, it was 2.101, right? Plus or minus, what was that number again? 0.004. grams, period. So that's what that statement would be like, but it's going to be your mass, your average, your standard deviation. Okay? Not the one I have up there. Anybody have any questions? Mm-hmm. Again, I would highly recommend you do it in pieces. Yeah. Because if you try to do it all in one go, you are going to misplace some parentheses. Well, that's why I wrote down these. That's what those are in the form. So right up here, this actually won't actually fit on one board if I were to write everything in there, so you could actually read it. And again, I would not plug it in all as one go. Okay. But what we have here is we have this portion right here, which is the xi minus 1, right? So that xi minus the average. That's what we did right here. See, this is the square. So we square the stuff in the parentheses here. Okay. Then the next thing we did is we do the average right here. This part is actually doing the average. That was the average. Okay. This is the part where we figure n minus 1. This right here is where we actually take that number from, right? This is where we take the square. So I've just done that in order of operations. So we know. And you can see it would have been. And I would not recommend you ever do a formula. It's long. It's many steps. Trying to do it all in one go. Yeah. You were next. That's sum up. That's upsum. Yeah, that's yeah.
Why is it right? Looks like it's not right.
So the epsilon here is actually acting on these. You see over here. So this sum of, and then it was n up here, I believe, and I equals 1. I can't see. Okay, and then up here was the x. So what it's telling you is this is acting. So everything that follows this sum up, what I'm calling it sum up, it's the sum of everything following. It's literally telling you figure these out individually, then take the sum. Also, one of the reasons why I don't typically ever do sum ups, like a single, because it's telling you this stuff, then take the sum. They can be very long. Like I mentioned, 3 is very short. Any more questions? That just whole section a lot. That's this. So you read that section, you notice it says 1982. So basically, if your pennies match around 2.5, you use 2.5. Match around 3, I believe the number, isn't it? If they're close to 3.1, you use the number 3.1. That would be your theoretical number. And so for us, we would use 2.5. Our number is really off. Main number specifically that number. So we take 2.5 minus average, so 2.101 in this case, then divide it by 2.5. This means absolute value. So if it's negative, so okay. No matter what, you're going to get a positive number out. And then you times by 100 to get in percent.
So in this
It depends on what your pennies year was. And your pennies year in this case is going to be the 2.5. I believe I gave you 2.5. That's the number of pennies we measured. So we measured out 3 pennies. If you were to measure 4 pennies and 4 here, this is actually your population. So if you did 1,000 measurements, that'd be okay. Any other questions? Okay. By the way, if you end up doing this in Excel, you'll still have to show the work on the packet, but you can check yourself really easy on Excel. Literally, you can, or Google Sheets. You can just put all your numbers and then go equals sum and then highlight your numbers. And it'll actually do all these things. Or you can put standard deviation, it will again do it. Okay. Be careful, there's 2 different types of standard deviation. There's a whole population and partial population one. This one is called partial population. You can know that because it has n minus 1. If it had n down here, it's the whole population. Okay. Any other questions? All right. I don't know how much I actually got recorded there, but